get this going. So let's do some ACT problems. So we left off on number 31 last time. So let's start with that one. It's a reader too. I'm not very good at reading. Okay. So let's see. Should we zoom out so we can see better? Alright, cool. Alright, so let's read it. Jen is doing an experiment to determine whether a high-protein food affects the ability of white mice to find their way through a maze. The mice in the experimental group were given the high-protein food. The mice in the control group were given regular food. Jen then timed the mice as they found their way through the maze. The table below shows the results. Like usual, I didn't even need to read any of that. But, here we are. So the average time the mice in the experimental group took to find their way through the maze was how many seconds less than the average time taken by the mice in the control group. Oh, so we just got to average them. Oh, definitely going to use a calculator for that. So, oh, you know what? Here's where all my old work is, over here. Cool. Alright. Zoom out again. So we're just going to average. So I'm not really going to try to be fancy about it. I'm just going to really put it in the calculator. Is there any good way to split screen? Not that I know of. Okay. So we're just going to do... let's put it in terms of seconds. So 106 plus 122 plus 140 plus 60 plus 51, 111 plus 101. Add those together, divide by 5. So that average is 116. And then I'm just going to do the exact same thing for the other side. So this would be a lot quicker if I had like a handheld calculator. So we're going to do 133 plus 109 plus 120, 148. Suppose I could have subtracted a minute off of all of them. 127. 118. Divided by 5. 127. So that averages 127. So that's 11 difference. It's not bad. That's not bad. Okay. 32. In the United States, phone numbers begin with a 3-digit area code. Now, there are restrictions on some of the digits, but in the future, as more and more area codes are needed, if the restrictions are needed, the restrictions may need to be lifted. If and when there are no restrictions, and each of the 3 digits can be any integer from 0 to 9, how many area codes will be possible? So if any of them can be 0 to 9, that means there's 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 possibilities for each place. So that's 10 times 10 times 10. 10 cubed. That's 1,000. Cool. Yeah, no restrictions. Alright. Oh, it's a little scarier maybe. So that function is graphed in the standard xy coordinate plane. How many x-intercepts does the graph have on the interval from 0 to 1? Oh, sheesh, you just gotta count them. So they're not counting 0 and 1. So 1, 2, 3, 4, 5, 6, 7. Oh, so that was scary. I thought that was gonna be hard. That was no problem. You just had to look at it. Okay, 34. If both x and that are positive integers, what is the least possible value of x? So That means it has to be divisible by both of those, right? By both 7 and 9. So is it 63? So it definitely works if it's 63. So it's not K. So let's see. 21 is not going to work because it's going to leave the 9. 27 is not going to work because it's going to leave the 7. 36 leaves the 7 and not the other one. So yeah, J. So yeah, it was the what's that word? Least common multiple? It was the least common multiple of all of those denominators. Cool. Let's keep going. So one second. My mouse just seriously stopped working. I just replaced the batteries. There we go. What was I looking for? Whoa. Weird. Okay. Anyway. Where's that now? Alright. So in that parallelogram, ABCD shown below, everything is labeled, so I don't need to read that. What is bad? What is BAD? BAD? Oh, sheesh. What is BAD? Oh, well, so all the angles add up to 360. All the angles always add up to 360 in a quadrilateral. So we know that those together are 113. And we know there's two of them, so that's 226. So then, well, actually, we can just do 180, because then we're just going to divide by 2, since there's like two angles. And so I was going to do 360 minus 226. But if I just divide by 2, that's just 180 minus 113. And that's easier. So 67. That's BAD, right? That's the whole thing? Yeah. Alright. Given that DC is that many inches, what is the value of N? So DC is going to be the same as the top. So what we're doing is we're doing 2/3 N minus 5 equals 1/3 N plus 7. And we just got to solve that equation. So, I mean, at this point, we could just put it in numworks, but that would take longer for real. So I'm just going to multiply everything by 5. By 3, I mean, not 5. By 3. 21. And then just solve. So subtract the N and just get N over here, add the 15, and get 36 over here. So N should be 36. Yeah. I like it. If I make a mistake, call me out on it. I make a lot of mistakes. Alright, suppose AC are located at those points, respectively, in the standard plane. What's the point of E? What? Oh, we're talking about this again? Is E the midpoint? Yeah, E is the midpoint. We have AC or BD, right? Yeah, we have AC. So we just got to find the midpoint of these. So you just average them. So 30 plus 2 divided by 2 is 16. 10 plus 3 divided by 2 is... 10 plus 3 divided by 2 is 13 over 2. I mean, yeah, it's the midpoint, right? I'm a little suspicious about that 13 over 2, though. How many 7 over 2s there are? How are they getting 7 over 2s? They're subtracting them? We're not going to subtract them. It's not what you do to find the midpoint. You add them. Yeah, the answers are suspicious, but I'm pretty confident about that. AC, 210, 33. 210, 33. Yeah, okay, whatever. That makes sense. Okay. Which of the following triangles is congruent to ABE? C, D, E. So it's got to be in that proper order. C, D, E. C, D, E. Yeah. Okay. I'm happy. Which of the following expressions is equal to that for all... So we just got a FOIL. So that's a squared. And then we've got minus 2a root b plus a root b. So that's minus a root b plus 2b. No, minus 2b. Because it's a negative times a positive. A squared minus a root b minus 2b. That's b. Alright, cool. Cool. So a track for a model railway display is set up as two circles that are tangent to one another and have diameters of 30 feet and 50 feet respectively, as shown below. I am not good at reading. The engine of the train travels at a constant rate of 75 feet per minute. To the nearest minute, how many minutes does the engine take to go in a figure 8 pattern around the entire track exactly one time? So we gotta see how many feet is the perimeter, the circumference. So this has a radius of 15. Oh, well, it's just the diameter times pi. So that's 30 pi. This is 50 pi, which means the whole way is 80 pi. And what, 50 feet per minute. So it's got to go 80 pi feet, and we're going 75 feet per minute. So I'm not going to estimate. I'm just going to do that. 80 times pi divided by 75 is roughly 3.35. I mean, that's nearest, but that seems pretty lame. Is that right? I think so. Yeah, I don't know what else it would be. Okay. Oh. Okay. Well, so it's negative, so I'm going to make it 5/4 right away. And then it's 3 over 2, which means I'm doing the square root, and then I'm cubing it. So on the top, I'm going to get 5 root 5. On the bottom, I'm going to get 8. B. Alright, that was fine. So many of these problems are lame. I haven't found a single ACT problem that I'm like, oh, this is a nice problem. Whereas on the SAT, I did. I don't know if that's like, it's probably better. You probably don't want like crazy problems when you're taking a test like this, but it's way more fun. These are just kind of boring. Alright, what is the value of a positive real number x such that I mean, yeah, see, it's just 5. Like, what else would it be? Because you can rewrite this as like 25 to the negative 1, and then you make that 5 to the negative 2, and you can bring that out, and like, what would you need it to be? Yeah, you need that to be 5. So that when you brought that out, that would just go away, and it would just be negative 2. Yeah, that's just 5. I guess you really do need to know what logarithms are to do that. Alright, so those points lie on a line in the plane. Which of the following points also lies on the line? So we just got to find the slope, and then make sure the slope stays the same to that point. So let's see. Let's get the slope between these two is 2 over 4. So the slope is 1/2. Okay. I don't really see a good way to do this necessarily. I guess maybe go with 6, 0. So then I'm like negative 4 over negative 9. That's definitely not it. Negative 4 over negative 7. That's not it. Negative 2 over negative 5. That's not it. Negative 1 over negative 2. That's looking pretty good. And yeah, that's definitely it. You just gotta make sure the slopes are the same. That's the idea. Alright. Rhea and Sampath start running laps from the same... Oh, we're talking about the same thing. Oh, or are we not? No, we're not. Okay. So Raya and Sampath start running laps around the same starting line, from the same starting line, at the same time, and in the same direction on a certain indoor track. Raya completes one lap in 16 seconds, and Sampath completes the same lap in 28 seconds. Both continue running at their same respective rates and in the same direction for 10 minutes. Oh my gosh. What is the fewest number of seconds after starting that Raya and Sampath will again be at their starting line at the same time? Oh, this is like a Bell problem. You gotta like find the least common multiple. I mean, frick, I'll just do that on numworks. So here, I'm still gonna have to think about it though. Arithmetic, least common multiple of 16 and 28. 112. So after after 112 seconds, they're gonna be lined up, because like one of them will have done more laps. Like Raya will have done more laps, but they'll be at the same spot because least common multiple. Alright, the CUFO of Math King Enterprises estimates that if the company sets a price of C cents for each unit of their new product, then the weekly profit from selling the product will be modeled by that equation. According to this model, for which of the following values of C will the weekly profit be at the largest? Oh, so we got to find the top of the parabola. We got to find the vertex. So what is the vertex? Isn't it negative b over a? Negative b over 2a. Yeah, negative b over 2a. So b is 1600 over negative 8. 200. Cool. So that's like if you just know the vertex is negative b over 2a. Otherwise, you could have completed the square. Otherwise, you could use calculus, but we're assuming like you're definitely not supposed to know calculus for the ACT. But you can use the power rule, set it equal to 0 to see where the maximum is, and you get the same thing. So that's definitely right. Well, okay, so yeah, C value. That's the C value. It's not their profit. They could have asked for the profit, but that's the C value where it's got the highest profit. I guess also you could have just graphed it. Like we got numworks. We can just pull out numworks and go home, functions. What was the equation again? It was 1600. We'll put x instead. Minus 4x squared. Graph, plot. Yeah, no, just shows us right there. Alright. Given consecutive positive integers, a, b, c, d, such that they're in order, which of the following expressions has the greatest value? Ooh, that's a good problem. This is a good problem. Okay, so if the top of the fraction is bigger than the bottom, it's bigger than 1. So I think we could go for that first. So that gets knocked off. A is the smallest. A is smaller than B. B is smaller than C. C is smaller than D. Hold on. We need to think harder about this. The first good thinking problem. I was just complaining about that. Okay, so A, B, C, D. So I'm just gonna put numbers. I'm gonna put 1, 2, 3, 4 so I can just think about it better. Cause like this is 3/4, this is 2/3, this is 1/2. And which of those is bigger? 3/4 is the biggest one. So we can definitely get rid of that. If we did, this one would be 3 over 5. No, that's no good. This one would be 5 over 7. That's pretty good. If I multiply this by 7, I get 21 over 28. I multiply this by 4, I get 20 over 28. Oh, so H is bigger. That's sus. I didn't really do like real math to get that. I just kind of plugged in values. But like if it's going to work for all of them, we don't really know it's always going to be consistent, but based on how the question is worded, it has to be. that like always the case? I mean, that's definitely not always the case. Because D can be like friggin' massive. And C cannot be. Oh, they're consecutive. Okay, they're consecutive. Yeah, okay. I'm happy. H. I'm happy. Yeah. Okay. 47. The ratio of the perimeters of two squares is 2 to 3. If the area of the larger square is 324, what is the length in feet of the smaller square? So the larger square, I mean, what's the square root of 324? Is that one I should know? Probably. That does feel like it's real. Or it's an integer. Square root of 324, 18. So the area, the larger one has a side length of 18. The smaller one then would have a side length of 12. Because it's 2 to 3. You say 2 over 3 equals x over 18. And see, you got to multiply them by 6 to get 12. Yeah. Okay. What is the set of all integer solutions for this inequality? Oh. All integers. So I'm definitely going to add root 5 to both sides. And that's like 2. So that's like 1 plus some stuff. X. And this is like 6 plus some stuff. So what do we got? We got 2, we got 3, we got 4, we got 5, and we got 6. 2, 3, 4, 5, 6. G. Okay. Wind blowing against a flat surface exerts a maximum force of that, where S is the surface area, V is the wind's velocity, and K is the constant. That makes sense. If a 40-mile-per-hour wind can exert a maximum force of 50 pounds on a 1 square foot flat surface, what is the maximum force in pounds? Okay, so I gotta solve for the constant first. This is like an SAT thing. So you plug stuff into the problem. So 40 miles per hour is the V. So we're gonna say K, S is 1, times V squared is 50. Which means K is 50 over 40 squared. So then 50 over 40 squared times 80 squared times 2. So here's what we're going to do. So we're going to cancel out and make that 2 squared. Still squared. So that's 100 times 4, so that should be 400. 400. Alright. So Roger will pour concrete to make a sidewalk with the dimensions in feet shown in the figure below. He will pour the concrete to a depth of 4 inches. One bag of concrete makes 0.6 cubic feet of concrete. What is the least whole number of bags of concrete mixed that Roger uses to make a sidewalk? Okay. We're assuming this is, that's in feet, and it's 4 inches. So we gotta talk about the area here. That area is 40. That side length is 16. So 16 times 4 is 64. So 64 plus 40 is 104. And a fourth of an inch, that's a third of a foot. I could just divide that by 3. That's not evenly divisible by 3 though. So, I'll still, it's all in feet. So I'll divide that by 3. So that's in cubic feet. And then I'm going to divide again by 0.6 to cancel out the cubic feet and put it into bags of concrete. So that should be the answer. 104 divided by 3 times 0.6. 58. He's going to need 58 bags. Hey, that's an answer. The least whole number of bags, yeah, he can't do 57 because then he won't have enough to finish. Alright, we're getting there. I imagine these are the tougher ones at the end. So hopefully they're a little more interesting. So I hate that they have a whole paragraph just describing the thing. It's like, I guess if you were blind, you would need that, but if you're blind, you couldn't read this stuff anyway. Oh, then they give you hints. We have a calculator, fools. Alright. Which of the following values is closest to the length of BP? Whoa. They don't tell us what the radius of the circle is? Oh, we figure out the radius because we can say that the tangent of 20 is x over 12. So, radius over 12, really. So, the radius is 12 tan 20. And then we want to know what BP is. So then we're going to do that cosine of 20 is 12 over x. So x is 12 over cosine 20. And then we're going to subtract 12 tan 20. And that should be the answer. I'm just going to go ahead and do that exact. I have to make sure my calculator's in the right setting then. It's probably not. Ooh, it is. Degrees. Okay. So calculator. So what was it again? It was 12 divided by cosine 20. Minus 12 tan 20. 8.4. Cool. Cool. Alright. The average of 10 test scores is X. When the highest score and lowest score are removed from the 10 scores, the highest score and lowest score are removed from the 10 scores, the average is Y. Which of the following is expression for the average of the highest and lowest scores? Whoa. Okay. So the average of 10 scores is X. So X equals over 10. So you add them all together. 10x is all of them added together. So we're saying I'm going to add them all together. But then subtract this lowest and highest. And then I'm going to divide by 8. And that should be y. So now I just need to find a plus b over 2, which I should be able to do. I can cross multiply and then schmoody stuff around and get that a plus b is 10x plus 8y, and I should just be able to divide everything by 2. Oh, which these fools are so lame, they don't even simplify. So h, I like it, I like it. $53, which of the following is a solution set? So, oh wow, quadratic. So we gotta do the compare things. So we make this 27 cubed, n squared, or 3 cubed, n squared. And we make this 3 squared, 5n minus 4. Which means that 3n squared equals 10n minus 8. So we've got 3n squared minus 10n plus 8. I'm gonna use the Richmond method because I have to. 6 and 4, 6 and 4. So the answers are 6 and 4. Or not. Ah, no, because then I have to divide. So, forgot the last step of the Richmond method. So we got n minus 6, n minus 4, and then I'm going to divide both of those by 3. So it's 2 and 4/3. Nice. Alright. each face of two cubes with faces numbered from 1 through 6 has a 1/6 chance of landing up when the two cubes are tossed, obviously. What is the probability that the sum of the numbers on the faces landing up will be less than 6? Less than 6. So, sheesh. So a lot of times what you do is you kind of make up a whole sample space type of thing. So you're like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then each of these are sections. And so then you say like which of these adds up to less than 6. So definitely here less than 6. So those is 1 and 5 is 6. 2 and 1, 2 and 2, 2 and 3, 3 and 1, 3 and 2, 4 and 1. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36, which is 5 out of 18. Yeah. Alright, we are almost done. At 2 p.m., Louisa leaves Kansas City in her car traveling east on I-70 towards St. Louis. Louisa from St. Louis at an average speed of 60 miles per hour, 68 miles per hour. At precisely that time, Antonio, who is probably going to San Antonio, Texas, leaves St. Louis in his car traveling west on I-70 towards Kansas City at an average speed of 57 miles per hour. The driving distance from St. Louis to Kansas City is 240 miles. At what time to the nearest minute will they drive past each other? Whoa, okay. So, she's going 68 miles per hour. And she's going to go for T hours. And we need that to equal the other side. So 240 minus 57 miles per hour times T hours. So 68T equals 240 minus 57T. So we're just going to add that to both sides and get 125. That's 57 plus 68. 270. Yeah, 125. So 125T is 240. So we're looking at 240 over 125 hours. And then it looks like we need to go into minutes. So we're going to say that 1 hour is 60 minutes. And so that's what we're going to do. 240 times 60 over 125. 240 times 60 over 125. About a minute 15. So if they leave at 2. No, it's 115 minutes. So that's an hour 45. So 3:45. I really got that it should have been 3:45, but whatever. Alright. There are 10 points on a plane and no 3 of the points are collinear. These 2 points, taken 2 points at a time, determine how many distinct lines. Is that even a full sentence, dude? So none of the 3 points are collinear, so it's just 10 times 9 divided by 2, 45. Is if you do just like 10 to the, like all 10 to all 9, you're counting 2 of them twice. So you gotta divide by 2, 45. Wait, did I mess up on the other one? It's negative 8y. Where did I even use that? Was that a long time ago? I'm not good at paying attention. Why is this negative 8y? I don't think it's negative 8y. Oh, shoot. You're right. It is negative 8y. Oh, I missed that. You're right. That is J. I don't think I get a perfect score on the ACT. It's kind of grueling. Alright, well, you're probably gone by now, but thank you anyway. Alright. Expression that reads as factorial. Yeah, they're just telling me what a factorial is. So when n is a positive integer, what is that equivalent to? So the idea here is that you can see it with this 6. So this is 6 times 5 times 4 times 3 times 2 times 1. And this 3 factorial is 3 times 2 times 1. So you can see that this whole last bit cancels, and you just have 6 times 5 times 4. And when you could do the same thing with this n plus 1 factorial, because really that's n plus 1 times n factorial. You would just keep going. And then it's being divided by n factorial. So that cancels out. So it should just be n plus 1 times 6 times 5 times 4. That's 120. 120 times n plus 1. That should work out. Okay. Which of the following must be true for each set of 4 consecutive positive integers? 4 consecutive positive integers. At least one of the integers is prime. That's definitely not true. At least 2 of the 4 integers have a common prime factor. At least 2 of the integers have a common prime factor. That's true because they would have 2 as a common prime factor. So 2 is good. At least 1 of the 4 integers is a factor of at least 1 of the 3 other integers. That's definitely not true. So it's definitely just G. It's definitely just 2. Yeah, that's a familiar question, actually. When x plus 1 to the 4th is expanded and like terms are combined, what is the coefficient of x squared? So this is a little Pascal's triangle, a little baby Pascal's triangle. So that's squared, that's to the 3rd, this is to the 4th. So the x squared term, we'd have x to the 4th, x cubed, x squared, so 6. Yeah, that was an easy Pascal's triangle. Alright, last problem, and then we get to check our answers. A hill makes an angle of 20 degrees. This is one of those things I don't have to read because it's just a drawing, right? Yeah. Ooh, this looks fun. Law of cosines. Okay, given that the length of it is AC, which of the following expressions represents the length of the guy wire? Right here. Cool. Directly above where the pool is inserted, given the length of AC is 60. Yeah, we got that. Oh, yeah, we got everything? No, we don't have some stuff. What do I need? So we got that angle, which means we got that angle, which means we've got this angle. Okay, now we can do it. So yeah, that's law of cosines. So c squared, which is what we want, x squared equals 25 squared plus 60 squared minus 2 times 25 times 60 times cosine of 110. Okay. Okay. So 25 squared plus 60 squared plus 2 times 25 times 60 times cosine of 110. And then we're going to square root that entire answer. 56.56. Ah! Ugh. I didn't even have to do that. It's K. Alright. Should I check the answers now? That's the best way. I can duplicate this tab. And I think I'm going to pull it off screen. Off screen. So I can look at it better. Okay. Answers. Cool. Okay. English. Math. Alright. Let's go to the top. Okay. So we're looking at E, H, B, J. Whoa, I got 5 wrong. Holy frick. What is the part of selecting a button that's not white? Not white is 10 out of 22. Do I just suck at math? I think that's what it is. Yeah, I think that's what it is. Alright. Anyway, 6F, 7B, 8H, 9C, and then J, and then 8, 11's, what, 12 is, 11C, 12, what? No. Greater. I literally can't read. God. Frickin'. Ugh. Yeah. Obviously it's not that. Obviously it's H. Okay. Man. Checking your answers is depressing sometimes. 13E. 14H. 15D. 16F. 17C, 18G, 19A, 20J, 21B, 22H, 23A, and then F, and then scroll down, E on 27. Whoa. 24F, 25C, 26F, 27E, 28H, 29E, and 30F. Alright, so I missed 2 up there. It's not horrible, I guess. It's kind of upsetting, but it was mainly just reading problems. The first one was just dumb. I don't even know how I made that mistake. I almost want to look back and see how I made that mistake. But then I couldn't read. I'm not very good at reading. Alright, 31B, 32K, 33C, 34J, 35D, 36K, 37E, 38K, 39B, 40H, 41B, 42F, 43D, 44G, 45D, 46H, 47A, 48G, 49D, 50J, 51E, 52J. Right, because I already fixed that. So that's like a third one, really, that I got wrong. 53E, 54G, 55D. Ah! Ugh! Alright. I really didn't think this one through too much, but I really did think that I got it right. Because you got, that gets her distance traveled, 68 times t. The 57 times t gets his distance traveled, and we got to do 240 minus that. So I like 125 t equals hold on. We solve for t in hours. Yeah, is that what we did though? 240 over 25, 240 times 60 divided by 25 is going to get you the time traveled. 240 times 60 divided by 25. 240 times 60 divided by 25. 125 is 115.2 minutes. 115.2 minutes is 55. Oh, yeah. Is that just like I can't add teen numbers together? Holy moly. Alright, 56J, 57A, 58G, 59E, and K. Alright. So I missed 4. Does this have a scoring guide? What? How does this score get calculated? So I'm trying to calculate my score. This mouse is having problems, and it's a real issue. Okay, so let's take a look at this together. So I got 4 wrong. Oh, no. I got 4 wrong. That puts me at a 35. That's not very good. Alright. Well, oh my gosh, can you imagine? Okay. Well, I think we're going to do science next. I don't think we're going to do anything right now. I think we might call it a day, unless you got any other ideas. But I was good. That was 48 minutes. That took way too long. Sheesh. I mean, I was talking through them too, and we even no. That's way too long. I spent too long on that second part. Well, it was less than 30 minutes for the first part, and that included a bunch of other time, and this included a bunch of other time too. So I suppose that's not that bad. All right. Yeah, do science next time. That's what I'm thinking. I don't know if I want to just do it all right now. I'm pretty sure I've only done a science section of these once, and that was when I actually took the ACT myself. And I do remember that I didn't finish it. Because the key thing about the science section that's so different is you can't read it. You don't have time to read all the stuff. It doesn't matter. Like, here's our science section. This, just don't even pay attention to all this over here. Just, like, don't even. Really, all that matters generally is the graph. At least I think that's my advice. I remember when I took it, that's what I figured out. And that's what I used for, like, the second couple problems. Yeah, that'd be good to get a 33. I did not get a 33 when I took it. I don't remember really what I got. I remember I got a 35 on the math. So, consistent. And, I was either like a 30 or a 31 overall. Because I did so bad on the science and the reading sections. I did get a perfect score on the math SAT, though, recently. Not when I was in high school, but recently I retook it. And I got a perfect score on the math part. So, yeah. 4 plus 12, 15. That's an easy one. We could do this. Play a game. Oh. Play some Poly Bridge. I like to do these weekly levels. They're fun. Oh, 17.5. Oh, I knew I was off by a little bit. Not far off. Only 2.5 off. My computer might not be able to handle this, honestly. Looking at this level, I probably can't even handle this level. Oh my gosh, look at that lag. Yeah, that's not very good. What on earth is this? What on earth? My computer specs? I don't even know what the best way to show that is. The screen I keep up generally is this guy right here. I'm not good with computers. My problem is, yeah, I got two graphics cards. One is like a not very good graphics card, and the other one is a really shitty graphics card. And it like only uses the really shitty graphics card. I like can't even move my task manager screen. Like this is what I'm looking at right now. We got you can't even still see. I can't even move my mouse. I mean, the problem is like I'm also streaming. My computer can handle just playing the game, but like I'm streaming this to YouTube right now. And you can tell, I mean, my video is super glitchy. It's not even going. But yeah. This is what we're looking at right now. In Windows search bar, I mean, I don't know what more you want to see. We're looking at this. Yeah, I know, 100% GPU. Do you know how to use the better? Because I'm using the other one 4%. It's using my crappy one 100%. How can I use like my not crappy one more? It's mainly just when I play games. Normally it's like okay, but when I'm trying to do like other stuff, it doesn't go so well. Like I can't even hit play. Well, okay. I mean, it's using both of them. It's not like it's. And I've looked it up a little bit. Apparently, there's some sort of like something you can do, but it uses both of them, just not perfectly. So this is an interesting level, but I can't play it while I'm streaming. I can play it when I'm like streaming to TikTok, but I can't play this when I'm streaming to YouTube. This looks way too hard anyway. I don't even like these hard levels. Alright. Well, I think I'm going to call it. That was a good time. That was, yeah, that was useful. So, yeah, I don't know if next time I'll do the ACT section. We've also got a Mu Alpha Theta competition coming up. I don't know if anybody knows about that. I think that's more of a Florida thing. But it's a good time. Yeah, play Fortnite, way more math. Definitely way more math. For this polybridge game, I've literally used sine and cosine before to calculate where stuff needed to be. I'm pretty sure I've used Pythagorean theorem too to find like the lengths of stuff. So I can't even like close this game. regain control of my computer, please. Thank you. Alright. Dude, trig is beautiful. You ever use trig while building in Fortnite? I don't know if that's applicable or not. I haven't really played much Fortnite. Yeah, and then my mouse is driving me crazy too. I don't even know. I literally just put in new batteries yesterday. Actually, this might not be a new battery, to be honest. This might be my old one. Trig is calc. Calc is trig. Alright, so what I think we're going to do tomorrow, maybe, is some off with theta problems. So those are like tough problems. Those are like actually difficult, rather than the ACT that are like easy. I just get them wrong for no reason. So that's what we're going to be looking at for